Okay, good morning everyone. So welcome back from your June holidays. Hope you have brought your chemistry file. Okay, so for today's first lesson, okay, for this semester, okay, we are going to start with Unit 4, acid bases as well as salts. Okay, so some of the things that you need from the earlier semester is your chemical formulas as well as chemical equations. Okay, so this unit 4 is worth around 2 chapters, acid bases as well as salts. Okay, so if you want to refer to your textbook, but you don't really have to lah. Okay, but if you want to, this is chapter 8 and 9 okay, on the textbook. Okay, chapter 8 and 9 on the textbook. Okay, acid bases as well as salts. Okay, a pretty conceptual chapter if you ask me. Alright, so write your name, class is Ficus, date you can put down as 26th of June, which is today's date, 2023. Alright, the next thing I need you to do is to update your content page. Okay, so just pause the video and update item number 18, unit 4, acid bases and salts. Today's date 26th of June 23 as well as notes. Yeah, okay, then I'll get started with the chapter. Okay, you can pause it and update first before we start. Yeah, thank you. Alright, okay, so first thing first, okay, I think this one you have briefly learned it when you are lower sec, okay, about reactions of acids and alkaline, some word equation, but we're going to go a bit deeper lah, and explore a few other things like basicity, strengths of acids, those kind of things. Okay, so a bit conceptual. Okay, and later on we will look at some questions in the assignment, first set of assignment on basicity, strength and concentration of acids. Okay, so this is a pretty conceptual question. Alright, okay, first part is quite conceptual. Okay, so that's why it's important to do the assignment, okay, in this part. Okay, so without further ado, okay, let's look at the definitions of acids and alkaline. Okay, so basically, okay, acid is a substance that dissociates in water to produce a H plus ion. Okay, whereas the alkaline is a substance that dissociates in water to produce hydroxide ions. Okay, so what do I mean by this, and what's the importance of the water in this definition is this. Okay, so water must be there for the dissociation of H plus and OH minus ions, so that an acid have its acidic properties, alkaline has its basic properties. Okay, so for example, okay, let's say you look at this little diagram down here. Okay, you put HCl, this is actually HCl gas. Okay, alright, so what happens is this, it's a molecule down here, it exists as a molecule. I hope you still remember how to draw a dot and cross. Okay, so there's no ions down here, but the moment, okay, you throw it inside water, what you notice is it breaks up, okay, into H plus and Cl minus. Okay, so down here is if I draw it a bit bigger, okay, but I think you can still refer to the diagram. Your eyes should be sharp enough. Okay, you break it down into H plus and Cl minus. Okay, so this is your H plus ions, okay, or if you name it out, it's called your hydrogen ions. I mean hydrogen without any electron already because hydrogen only got, if you refer to your periodic table, is 1 proton and 1 electron. There's no neutrons. Okay, so once it loses the electron, it's like that empty shell. Got nothing. Do you have a periodic table? Okay, yeah. Okay, if you refer to your periodic table, alright, going back, okay, so just like earlier chapters of all the notes, okay, what happened? Okay, is that we always have a periodic table at the back, so do refer to it. Okay, so only you have these H plus ions, then I can actually call it an acid. So without these H plus ions, it's actually not an acid. Alright, okay, so And water is required for it to dissociate. Dissociate means, if you put it in a very layman way, please don't write this in your exam, is breaking down into the ions, okay? Alright, so once you dissolve this HCl gas inside water, okay, you actually get H plus ions, your hydrogen ions. That's when it becomes an acid. It must have H plus, then then I can call it an acid. Right, so that's why the cations of acid is always a H plus. Okay, alkaline follows a very similar definition, just that it's the hydroxide ions. So let's say you have NaOH, sodium hydroxide. Only when you throw it inside water, you have Na plus and OH minus. Okay, so this is your OH minus ions, or what we call the hydroxide ions. Okay, alright, same thing, only when you throw it in water, then you will dissociate to produce your hydroxide ions, which means the HCl gas itself, this one is a molecule. So if you recall what you learned in bonding, molecule, because it's electrically neutral, it does not conduct electricity. So don't forget things that you learn in bonding. But once it dissociates in water, then you realize, hey, there's actually mobile ions. Okay, so acid is very unique. Okay, this one, when you dissociate in water, is HCl aqueous. It's a solution, basically. Alright, okay, HCl is a solution. Okay, only with that, then it has mobile ions, then can conduct electricity. Okay, so acid is very unique. Without water, it cannot conduct electricity. But once you dissolve it in water, hey, it actually dissociates to form H plus ions. So as a result, got mobile ions, then it can conduct electricity. Alright, so acid is always a solution. Okay, so there's like a myth, so-called, there's no such thing as a pure acid. Okay, if someone ever tells you there's a pure acid, actually they are lying to you. There's no such thing. Because why? Acid is always a solution. It's always a mixture. That means to say, okay, acid is always a solution. That means it's a mixture. Because it's always the acid itself plus water. Okay, so it's always a mixture. Okay, there's no such thing as a pure acid, actually. Okay, so it's always a solution, which means to say it's always a mixture. Solution because it dissolves in water. Okay, likewise for alkaline. Okay, but alkaline is actually belongs to a larger category of chemicals known as the bases. Okay, so what are bases? Metal hydroxides and oxides are bases. Okay, I'm short of space. Maybe I'll erase this. Okay, so bases is actually a larger category. Okay, for alkalines. So bases, what are they? They are actually metal oxides or hydroxides. Okay, many examples like copper 2 oxide, sodium hydroxide, potassium, all the metal oxides and hydroxides, they are bases. Okay, so bases got two categories. One is soluble in water, the other one is insoluble in water. Okay, the ones that are soluble in water, we call them alkalines. Okay, basically they are the group 1's hydroxide, or otherwise 1BC. I will call them 1BC. Okay, I should write a normal one. Okay, group 1, barium and calcium. Okay, hydroxides. 1BC. Later on you will learn the solubility, which I think I briefly covered with you in chemical equation and formula unit 3. Alright, before your mid-years. Okay, so only soluble bases we can call them alkalines. Okay, soluble ones are called alkalines, but the insoluble ones, we just call them bases. So basically all alkalines are bases, but not all bases are alkaline. If you understand what I mean by this statement, I repeat again. All alkalines are bases, but not all bases are alkaline. Alright? All right. Okay, so this is just a touch up lah on what I mentioned earlier, that hydrogen chloride gas is it an acid? Answer is no lah. Okay, because hydrogen gas, as you can see in this diagram, it exists as a simple molecule. When it does not dissolve inside water, it cannot ionize into hydrogen. Ionize is another word for dissociate lah. Okay, so in fact I use them quite interchangeably. Okay, ionize is dissociate, dissociate is ionize. Basically, put it in very layman terms, is breaking down into the ions itself. Okay, so once again, another diagram just to show you, okay, the importance of water. All right, okay. Wait, okay. All right, so what you notice is that when you dissolve it in water, okay, the hydrogen chloride will ionize into hydrogen ions and chloride ions. Okay, that allows it to react with the magnesium metal. Okay, but if you don't, okay, then it exists as a molecule. Okay, so it does not ionize to produce H plus ions. So without the H plus ion, it's actually not an acid. Okay, so there will be no reaction. Okay, and to represent this dissociation, okay, we actually use this equation down here. Just make it slightly clearer to you. Might not be very clear on the diagram inside your notes. Okay, so this is what happened. Okay, HCl aqueous break down into H plus and Cl minus aqueous. Okay, so this is the equation, okay, for the dissociation of HCl. Alright, but if you put it in any kind of solvent, it will not dissociate lah. Okay, it will just remain as a simple molecule. Then there's no H plus. Then basically it's not an acid lah. Alright. Okay, so some properties of acids and alkalines that you probably would have learned in lower sec. Okay, things like acid has a sour taste. And then when you test it with moist, okay, the word moist is important. Sometimes common mistake, people always miss out the word moist. Okay, moist blue litmus paper actually turns red. Must be moist because need water for the dissociation. Okay, then your acid will dissolve in water to form solutions to conduct electricity. This was what I mentioned earlier on. Because of the presence of the mobile H plus and Cl minus, H plus ions. Okay. Okay, then you have the alkaline, which is beetles, feels soapy. And then alkaline will turn, you use a red litmus paper to test for it, then it will turn blue. Okay, whereas for acid, you use a blue litmus paper, then it will turn red. Alright. Okay, likewise, alkaline, there are mobile ions, so can also conduct electricity. Alright. Okay. So then the next thing, okay, we have the strengths. Okay, so this is the first important concept. Okay, after the definitions of what's an acid, what's a base. Okay, actually the second most important thing. Okay. Alright, okay. So every big box is one important concept that you ought to know, so called. Every box like this. Yeah, that's what I meant. A box like this. Alright. Okay, so okay, we'll talk about the strength. Okay, so when it comes to strength, one thing important is, okay, we use strength. That means we say it's a strong acid or a weak acid. Okay, but strong and weak in this case has nothing to do with the concentration. Okay. Okay, one thing I think you should take note is never to confuse the strength with the concentration of the acid. Okay, and then another two things that you got to differentiate very, very clearly, okay, I'm going to highlight in yellow, is the concentration of the acid, or am I talking about the concentration of the hydrogen ions? That means the H plus ions. There are two different things. Concentration of acid and concentration of the H plus ions. There are two different things. I highlight again. Be mindful, because these are actually two different things. Okay, what do I mean by that? Okay. Okay, so let's tie in that together with the definition of a strong acid as well as a weak acid. Okay, what do I mean by a strong acid? Okay, strong acid is one that completely dissociates in water to produce H plus ions. Okay, usually it will result in a high concentration. Okay, I write short form okay, of H plus ions. Concentration of long form is like that okay, but I tend to have a habit to be quick during lesson. I'll write CONC to represent concentration, okay? Whereas weak acid is one that only partially dissociates or ionizes in water to produce H plus ions. Usually, it will give you a low concentration. Okay, you cannot write CONC. I can write, you cannot. You must spell the whole thing. Okay, so low concentration of H plus ions. Okay, so what do I mean by partial dissociation and full dissociation? Okay, maybe let me scroll to the side so I got some space to illustrate to you. Okay, strong acids typically are the ones that you see inside a lab bench. Okay, like hydrochloric acid, nitric acid, sulfuric acid. Okay, and you notice when I represent it using an equation, chemical equation, it's actually a one-headed arrow. But weak acid, when I say it partially dissociate, when I represent it in equation, you notice there's this like strange looking double-headed arrow. It looks like this. This double-headed arrow. Okay, but what actually it means, okay, when I see it visually is this. Okay, you imagine, you put four, okay, imagine the numbers are purely just for illustration, not a real case. Okay, you put these 4 molecules of HCl inside a beaker of water. This is water. Okay, what happens is that it will all break down into the ions, all 4. You see? All 4 break down into the ions. Okay. Alright, all 4 break down into the ions. Okay, but if you were to break ethanoic acid, okay, this is actually the main acid that you find inside vinegar okay, not 100% acid okay, is this okay, I shall simplify it because this one ethanoic acid, the formula is very long, CH3COOH. You'll learn more about it next year in organic chemistry, but for now I shall just simplify it to HA okay. So only the last H can be dissociated, alright. Okay, only the last one on the right. Okay, I simplify it to HA okay. As you can see okay. So what happens is I put in 4 of this ethanoic acid 4 molecules. Again, I have my beaker of water, then can dissociate. Same thing still an acid. Need water, then can dissociate. Okay, is that you notice there's only 1 molecule that will break. The remaining ones, actually they stay together still as a molecule despite me dissolving it in water. The rest doesn't dissociate. Okay, so it's like that. Okay, so what do I mean by completely dissociate is I put 4 molecules. All 4 will break down into the ions, dissociate into the ions. Okay, but for ethanoic acid, I put in all 4, only 1 will dissociate. Okay, the numbers are really I blown it out a bit okay. If I blow it out a bit, it's like I put in 1,000 molecule of HCl, all 1,000 will dissociate. Okay, but if I put in 1,000 molecule of the ethanoic acid, only 4 will dissociate. That's literally how low the number is Okay, so when I represent it, okay, when I look at it together with the concentration of the acid, okay, I'm going to tell you a bit ahead of time the units for concentration. Okay, So I have 1 mole per dm cube. 1 mole per dm cube is the units. Okay, you don't care what exactly it means at this point of time. Okay, just treat it like any other units. Okay, I will have 1 mole per dm cube. Okay, for the concentration of my H plus ions. This one is my concentration of acid. Okay, can? Okay, but if I have this ethanoic acid, okay, then I represent it using a double-headed arrow to show partial dissociation. Okay, so concentration of acid. Okay, let's say I put it as 1 mole per dm cube. The concentration of H plus because of partial dissociation is probably like as low as this. Very, very low compared to the concentration of acid. Because I put in like 10,000 molecules, only like 4 will dissociate. That's why it's so low, 0.004. Okay? Because this concentration of H plus will affect the pH, later on you will learn. Alright, so it's important you get this concept of what's partial and what's fully dissociate. This one is fully dissociate. The one at the bottom is your partial dissociate. Okay, that's the meaning. Alright. Okay, and then concentration of acid and concentration of H plus is actually two different things. Concentration of acid is like how much of the acid I dissolve in the solution. Okay, so that brings me to the next point. Whether it's concentrated or dilute acid, it basically just tells us how much of the acid I put inside the water. And nothing to do with the strength. Okay, strength is something like intrinsic. Okay, it's like the nature of the acid. Okay, you can't control it. If it's a strong acid, it's a strong acid. If it's a weak acid, it's a weak acid. So usually it's the minerals acid. Okay, we call this kind of acid the weak acid. Usually we call it like ethanoic acid is the organic acid. But of course there are some like carbonic acid that we find inside a soft drink. It's also a weak acid. Alright, so all these strong acids, they are actually the mineral acids. Okay, we will largely look at strong acids most of the time in this chapter, to be frank. Okay, so strength of the acid is not affected by the concentration. Okay, concentration of acid doesn't affect the strength. There are two different factors. Okay, so dilute acid doesn't mean it's a weak acid. Concentrated acid doesn't mean it's a strong acid. Alright. Okay, and then the question is, does strength of acid affects the concentration of H plus? Yes. Okay, because just look at this example on the right, you know why. Okay, where the strength of the acid affects concentration of H plus. Okay, because usually the concentration of H plus will be high if it's a strong acid, because it fully dissociates. Then concentration of H plus for weak acid. Okay, this case at the bottom is a weak acid. The one at the top is a strong acid. Okay, so usually for a weak acid, because of the partial dissociation, concentration of H plus will be low. Okay, compared to concentration of acid.